Welcome to ISL enabled virtual lab of CSIR.
Electrical conductivity of different solutions. In this experiment, we have to observe the electrical conductivity of different solutions by using a simple electrochemical setup and to see whether the bulb in the circuit glows or not. For this experiment, we take 4 different types of solution. These are 0.1 molar HCl, 0.1 molar NaOH, alcohol solution and glucose solution, and 4 beakers for each solutions. Now for the circuit to flow electricity, we take 2 nails, a 6-volt battery, a bulb, a switch and wire, and after that connect them in an electrical circuit. First, experiment with dilute hydrochloric acid. Concentration 0.1 molar. We now take the initial solution, which is 0.1 molar dilute hydrochloric acid, and then after adding 40 ml of solution to the beaker, insert the nails into the solution and space them apart. Finally, flip the switch on to close the circuit and observe the bulbs. Observation: the bulb glows brightly. This is because hydrochloric acid dissociates into ions like H plus and Cl minus in solution, and it acts as an electrolyte which allows electric current to pass through the solution. The dissociation is HCl gives rise to H plus plus Cl minus. Now experiment with dilute sodium hydroxide. Concentration 0.1 molar. Now for the second solution, 0.1 molar dilute sodium hydroxide solution is taken. Add 40 ml of solution to the beaker. Then insert the nails into the solution and space them apart. Lastly, close the circuit, turn the switch on and observe the bulbs. Observation: the bulb glows brightly. Sodium hydroxide is a strong electrolyte that dissociates into ions like Na plus and OH minus, allowing the current to flow through the solution. The dissociation goes like NaOH gives rise to Na plus and OH minus. Now let's discuss how current flows in an electrolyte solution. Application of voltage. When a voltage is applied across the electrolyte solution using 2 electrodes, the ions starts to move. Positive ions are attracted to the negative electrode. Negative ions are attracted to positive electrode. The movement of ions from one electrode to the other creates an electric current through the solution. The stronger the dissociation, the better the solution conduct electricity. Now for the third solution, we take glucose solution. Now add 40 ml of glucose solution to the beaker. Then put the nails into the solution containing glucose solution and space them apart. Now flip the switch on and observe. Observation: glucose is a molecular compound and not an ionic compound. When glucose dissolves in water, it does not ionize into charged particle like HCl. Instead, the glucose molecules simply dissolve as neutral molecule, unlike ionic compound, which breaks into ions in the solution. Glucose stays intact as a whole molecule and does not produce free ions to carry electrical charge, and for this reason the bulb does not glow. Now experiment with alcohol solution. Now for the fourth solution, we take alcohol solution and add 40 ml of alcohol solution. Then put the nails into the solution and space them apart in the beaker. Now flip the switch on and observe. Observation: the bulb does not glow because alcohols like ethanol contains a hydroxyl group attached to a carbon chain similar to glucose, while the hydroxyl group is polar and can make hydrogen bonds with water. Alcohols do not separate into ions when dissolved in water. Therefore, alcohol does not carry electricity. Conclusion: this experiment demonstrates the concept of electrical conductivity in solutions, which depends on the presence of free moving ions in the solution.